Hello everyone, my name is Francesco Cipollone. I'm the CEO and founder of Phoenix Security. Today, I want to talk with you about prioritization and what it means actually to prioritize vulnerabilities across your software supply chain and digital supply chain pipeline. Software supply is difficult to describe, and there is a lot of talk about prioritizing vulnerability with one method and another method. And I'm coming here to clarify some of the maybe misconception around the various aspects of vulnerabilities. Now, if we take infrastructure, container, clouds, prioritization, those could be your server, those could be your container deployed in a Kubernetes cluster or a cloud cluster, and we want to start prioritizing them. We start looking at vulnerability with, for example, a proof of concept. So there is a piece of code that is a malicious code in repository like GitHub or other places where you might find the vulnerability there. The challenge with this is there are around 17,000, if not even more, vulnerability with a potential exploit that is not verified, that is not maybe weaponizable, maybe not used by attackers. So it is a low quality way to prioritize vulnerability. Now, the next step is actually looking at a vulnerability if that vulnerability has an active exploit. And this is actually used in the wild. Information like EPSS and other source of threat intelligence might communicate us if an exploit is available, or location like exploit-DB, meta-exploit, nuclei, and other sorts of easy off-the-shelf attacks or attackable framework used by attacker and tester are potentially indicator for this active exploit. And those are much smaller in number. We're talking about instead of 10,000 or 15,000 or 17,000, much less, something like in the range of 2,000 to 5,000 vulnerability with active exploit, and even less if the exploit is non-active. Now, the other aspect to actually even narrowing down in your particular environment, right now we discuss if a vulnerability is useful or not, if it's present in the National Vulnerability Database or not. Now, if you want to narrow it down even more, you look at information like deployment. Is this particular piece of code or this particular infrastructure running in my production environment? And even more, is this part of one container that span up multiple versions of a container, and that's called a scale set. Now, if you see, we go from a very large scale, 207,000 vulnerability, to a very narrow down scale where we're talking about handful of vulnerability. That's one way to prioritize. Now, from a software perspective, the scenario is slightly different. When we start looking at the vulnerability with the availability of POC, the vulnerability, the scenario is more or less the same. We might have a lot of vulnerability. And then we start looking at narrowing down if a particular vulnerability has an active exploit, if there is a fix available. All of this information narrow down the number of vulnerability, again, from 17,000, 20,000 to a handful of thousands, like 2 to 3,000 set of vulnerability. And the one that have an actual exploit are even less. Now, again, the complexity comes when we start looking at intelligence, like is this particular piece of repo, piece of software deployable into production or deployed into production, and where it comes from and who maintains it. And then even narrow down if the particular function that this particular piece of code is using is even reachable or even used at all. A lot of open source libraries have a series of functions of which some of them might be vulnerable, some of them might not be vulnerable or not reachable, not fixable. And hence it creates noise. Sometimes it's easier to actually just upgrade the library rather than start looking at the reachability analysis, because it can be quite process intensive to look at reachability and requires code and library to be working together. Sometimes it's easier to just say this piece of code is deployed in production, hence we upgrade this library, because that library might be used or that function might be used at some stage. And there is an economy of scale when we look at if something is harder to automate or something is easier to automate. Looking at prioritizing vulnerability in bulk, if there is an active bug bounty, if something is exploitable, if the code is reachable, it's probably harder to understand where the piece of code or that particular vulnerability lives. Again, exploitability, location, and reachability analysis are easier and more deployable at scale. Attack path analysis is probably more complex. And then if we go even further, with criticality analysis, there is business criticality, there is an understanding if a particular application process card data or critical information for the client, and that's a business criticality analysis versus a full-fledged fair analysis that is a bit more complex to implement. And then the last part is deferring a specific set of vulnerability, because maybe there is a biggest upgrade coming up with Windows or an operating system, or those are potentially false positive. There is only so much system can do automatically and automagically. And the objective is to get to that nirvana at the end of the funnel of the prioritization with the least amount of things that need to be triaged at scale. And this is the benefit of application security posture management and solution like Phoenix Security that helps you prioritizing automatically and doing the things from S1 to S3 in an automated way. I hope this was informational, and I hope this clarified a little bit what the role of an application security posture management and the role of prioritization at scale, and how the pyramid of prioritization differ between infrastructure vulnerability, container and cloud, and software vulnerability, and how they operate at scale. Thank you very much. This is Francesco Cipollone. Stay safe out there and optimize your workflow with solutions that help you prioritizing vulnerability at scale. Thank you.